Let's look at the solutions of arithmetic bites. The average weight of 6 persons in a group was 62 kg. After 1 year, the average weight of the same group became 68 kg. If each person in the group gained at least 3 kg, what is the maximum weight that any person in the group could have gained? Okay. 6 persons have had their average weight increase by 6. So can I say the total increase in weight is 36? Total increase in weight of all the 6 people combined is 36. Now we have been told if each person in the group gained at least 3 kg, what is the maximum weight that any person in the group could have gained? Total increase has to be 36. For 5 people, I will give them the minimum increase, 15. So now the 6th person needs to have an increase of 21 so that the total increase is equivalent to 36. Answer to the first question is 21 kgs. Next, water is being poured into a tank at a constant rate using an inlet pipe. There are a number of outlet pipes of equal capacities attached to the tank. Initially, the tank is full and all the inlet and outlet pipes are open. It is observed 12 outlet pipes and an inlet pipe working together can empty the filled tank in 20 hours, while 15 outlet pipes and the same inlet pipe can empty the tank in 15 hours. In how much time would 6 outlet pipes along with an inlet pipe empty the tank if the tank is full? Okay. Simple things. We have got 2 workers of different efficiency, so we have to equate them. So let every outlet pipe have an efficiency of A, and the sole inlet pipe have an efficiency of B. So initially, total amount of work or the size of the tank will be given by 12A minus B. See why we are doing minus B is the inlet is sending in water, but eventually what you have is the tank getting emptied. This is their combined rate and they have to work for 20 hours. This is the size of the tank. In the second case also, size of the tank remains the same. That has not changed. In the second case also, size of the tank has not changed. So in that case, it will be equated and you'll have 15A minus B into 15. So I can now get the ratio between A and B. 48A minus 4B is equal to 45A minus 3B, or altogether it comes out to be 3A is equal to B. Okay. So inlet is as good as 3A. Inlet is operating with a rate of 3A. So now can I say the size of the tank will be 12A minus 3A. So 9A into 20. This is the entire size of the tank. You can also go ahead and do it here. You will have 15A minus 3A. So 12A into 15. Whichever way you choose to go. Finally, what do we have? 6 outlet pipes along with the inlet pipe. So 6 outlet pipes along with the inlet, or 6 outlet pipes along with the inlet. We'll get 180A by 3A. Cancel, cancel. We get 60 here. Same result you would get here. Answer is option D. Next question. There are 2 sections in standard 10th of a school, A and B. Number of students in section A and B are P and Q respectively. 15 students of section A are exchanged with 15 students of section B, and thereby the average weight of students in section A increases by 0.4 kg. Okay. The average weight of those 15 students of section B who were shifted to section A is 2 kg more than those 15 students of section A who have been shifted to section B. What is the value of P? This what should be in capital. Okay. So 2 things you need to know. The increase in total weight of section A, in average weight is 0.4 kg, but increase in total weight of section A is going to be P into 0.4. For every kid, the increase of 0.4 kg. So we get P into 0.4. Additionally, what we know is 15 kids, let's say they had an average of X from section A, and from section B, 15 kids had an average of X plus 2. If these people have exchanged sections, can you see that 15 into 2, you've got 30 kg extra in section A now? We've got 30 kg extra in section A, and this 30 kg is equivalent to total increase that is happening in section A. So P into 0.4 is equal to 30, or P is equal to 75. This is what the question asked. What is the value of P? Value of P is 75. Next question. Nilay and Rohan are two swimmers stationed at 2 points A and B respectively on a flowing river. The direction of flow of the river is from A toward B. When Nilay and Rohan swim towards each other, they meet at point C, which is at a distance of 20 meters from B. However, when Nilay and Rohan swim in the same direction downstream, then Nilay catches up with Rohan at point D, which is 40 meters from B. If the speed of Rohan in still water is 9 times the speed of river, then find the ratio of speed of Nilay and Rohan in still water. Okay, let us diagrammatically represent what is happening. This is A, this is B. Water is flowing this way. I've given the speed of water as x. So speed of Rohan will in still water will be 9x. He is moving this way. And Nilay, we don't know his speed. So I'll take that as n. And they meet at some point in between, which is 20 meters from B. Let's say this distance, this point was C. AC, I'm taking the distance as D. And CB, I'm taking the distance was given to us in the question as 20 meters. Now see, because Nilay and Rohan are both moving for equal duration of time, can I say the ratio of distance traveled by them would also be equal to the ratio of speeds that they have? So D by 20 has to be equal to ratio of speeds that they have. So speed with which Nilay is moving is n plus x, his own speed plus the influence of water, divided by Rohan is his own speed is 9x, water is working against him, so his speed is 8x. This much we have got from the first case. Now let's look at the second case. We have still got A, we have still got B, but in this case they meet further ahead. This is 40 meters. This time Rohan is moving this way. Nilay is still moving this way. His speed is n. His speed is 9x. Water is moving at the rate of x. But this time, do we note this entire distance is d plus 20 meters? This entire distance is d plus 20 meters. Same idea, because they are both moving for the same duration of time. The ratio of distances traveled by them should be equal to the ratio of the speeds. Ratio of distances traveled by Nilay, distance traveled by him is d plus 60. And distance traveled by Rohan is 40. And the speeds with which they are traveling is n plus x. Sorry, x, not 8. N plus x divided by Rohan will now be traveling. His original speed is 9x and water is helping him now. So his speed will be 10x. Now, when you look at these two expressions, all you need to do is divide one by the other. So I'm dividing this whole thing by d plus 60 by 40 is equal to n plus x by 10x. So n plus x gets cancelled entirely. X and x gets cancelled. This becomes 4. This becomes 5. This gets cancelled. This gets cancelled. Becomes 2. So 4 will come down. 5 will go up. Lots of processing. 5 by 4. So 10. So 10 times of d plus 60 is equal to how much? This goes to the top. 2d. Wait. 10 times over. This 2 goes to the top. 2d. 5d. So I have 10d on one side. On the other side, no, this will be 8d. I need to smoothen it out. I am making it more difficult for myself than it should be. I shouldn't skip steps. Okay. So I've got 2d by d plus 60 is equal to 5 by 4. Okay, fine. So we get 8d is equal to 5d plus 300, or d is equal to 100. Okay. If d is equal to 100, if d is equal to 100, I now get, I'm using this expression, original form, d by 20 will be equal to 5 now. So n plus x by 8x is equal to 5, or n plus x is equal to 40x, or n is equal to 39x. So speed of Nile is turning out to be 39x. Finally, we needed the ratio of speed of Nile and Rohan in still water. His speed in still water is 39x, his speed in still water is 9x. So the ratio of speed will of course be option A, 13:3. Last question. A car starts from point A and goes to another point B. In between A and B, there is a tunnel PQ of a certain length. A bicycle rider is standing at point R in the tunnel such that PR is to RQ is equal to 1:4. When the car starts from A, and if the bicycle rider start cycling towards P, he will meet the car at P. But if he cycles towards Q, the car will overtake him at Q. Which of the following is true? Okay. So let's say you had your car present here somewhere. This is point A. Then you have a tunnel somewhere in between. PQ. And the cycle rider is somewhere here. So if this distance is x, this distance is 4x, this is r, PR is to RQ is r. So I'm saying let this distance here be y. So if the car is going this way and the cycle rider is going this way, if the car is going this way and the cycle rider is going this way, they meet at P. Again, because the time for which they have been moving is identical, can I say I will take speed of car as A and speed of cyclist as B. Speed of car and speed of cyclist is equal to A by B. This will also be equal to Y by X, because this is the distance car has traveled, this is the distance cyclist has traveled. Okay, this is the first case. In the second case, what is happening is, if the cyclist started moving towards Q and the car was also moving towards Q, now the car would travel the entire distance y plus 5x and the cyclist would travel distance 4x. Because the speeds are still the same speeds, can I go y by x will be equal to y plus 5x whole thing divided by 4x. Yes, seems appropriate. Looking at these two parts, x and x gone, 3y is equal to 5x, or y by x is equal to 5 by 3. So this is wonderful. Why we needed 5 y by x is, finally the question asks me which of the following is true, and they're simply comparing speeds of the cars. So we got 5:3 here. We've got 5:3 here. After we've identified 5:3, that is the ratio of speed of car and the cyclist. The speed of car is 60% more than the speed of the bicycle rider. No. Speed of the car is 50% more than the speed of the bicycle rider. No. Speed of the car is 66.66%. It is 2/3 more. Yes. C should be the answer to this question. Hopefully you realize that it is not so much equations in TSD that matter. It is more interpreting the question correctly. That will be all. Hopefully you learned something. Okay, bye.